I'm going to introduce you today, Hamide. So thank you for
Thank you,
joining
Charlotte.
us. So it's my pleasure to introduce Associate Professor Hamide Amjomja. Hamide is a technical account manager at Groby Optimization, a decision scientist with more than a decade of experience in optimization, data science, and AI. She's also an associate investigator in Optima, previously being a chief investigator at Optima, and is very involved in our community. So we're really keen to hear more from Hamaday today. Um, IBM research in Australia, and she holds a PhD in mathematics and has worked for a long time at the University of Melbourne as well, and published widely in optimization and in real-world applied optimization. So welcome, Hamaday. Thanks for giving a talk today, and I'll leave it up to you.
Fantastic. Thank you so much, Charlotte, for the nice introduction. All right. And thank you, everyone, for joining us today. And today I'm going to go deep dive into a fascinating problem in optimization, but also very painful problem called infeasibility. So imagine you spend a lot of time to build a very complicated problem. You define your rules, decision variable, your objectives, and then you hit the button to solve, and everything. And but the solver comes back and says it is infeasible. There's no solution it can help you. And this has been studied for decades to see how we can analyze this infeasibility. And today, my talk, I try to focus on many audience, not only academic, but also for industry and practitioners here in the today meeting. And also they may want to watch the recording from Optima sometime in future. So today agenda is understanding what is infeasibility. What are we talking about when the solution there is impossible to give us any solution? We diagnose this infeasibility with IIS. I introduce it later in my talk, and also recover a workable solution around this. We call it Fees Relax. These are the cool things that would help us to understand how can we uh, recover from our infeasibility here. So my main things here, the first things I want to say, when you build your model and then the solver tells you it is infeasible, this is a kind of business alignment problem, not a maths problem, not a failure in the solver, not a glitchy answer. It's actually giving you some insight from the rules that you build in your optimization, in your modeling. That's the key things for the business stakeholders here. So the solver did exactly what you build your modeling here. It's not something that, just made it up. And the good things is it might also expose some of the hidden conflicts behind the business rules that you have. And here, if you use Gurobi, if you use other solvers, any solvers, it can sometimes they can go further and help you to navigate, okay, what is this? What's the trade-off? I'm in this situation. What should I do? Let's, as we have some audience from mathematics, they will always like to make sure we are on the same page with definition. What are we talking about in feasibility? So let's start with a sweet spot. What is feasible? What are we talking about the feasible here? When we have solution exists in shaded region, when in our constraints, when we have a nice spot and then it means that constraints all be satisfied. All of your business rules are satisfied. And this is a sweet spot that we want to see. This is feasible, but tell me something. What is the best among this? On the other side, we have an unbounded, which means that the feasible region has no upper bound. So objective, your goals can improve without any limitation. Sometimes it could be some glitch or we forget to put some boundary, but sometimes that's how it is. But the pain point here in the middle is the infeasible situation. When you put there's no overlap between your constraints, contradicts each other's all the time. And this is a scenario we want to investigate further. Let me start with some infeasibility in real world problem. I thought about different scenario. I thought maybe I start with use airline because I'm sure many of us have been tackling that our flight has been delayed or scheduled. But from the planners at the airport or airlines, this is I assume most case scenario every weekly they have to tackle this problem. They have a flight from Sydney to Melbourne cancelled with 180 passengers, and we have 3 hours to book them. The planner look at the schedule, say, okay, 140 seats remain available across all of the alternative flights that we have. But ouch, 40 passengers cannot accommodate to the rules. What should they do? There are a huge number of constraints in the airline they go through behind the scene when they are scheduling. But this is a scenario sometime with this kind of technique that I'm going to introduce you further mathematically, it can tell us, okay, these are the three constraints, you need to take care of them. It looks, these three constraints that you want all passengers reach to their destination today, plus having the capacity at each aircraft cannot be exceeded, so people cannot use one seat for two people at the same time. And the third one, which is passengers must travel direct, no stopovers. So these are the three rules. Sorry. So these are the three IIS can help the planners say these three are contradicting each other. This is very helpful because because it helps to see what they can navigate. Uh, Charlotte, is the ring for everyone or only me?
It was
Okay.
blinking before, but now it's fine.
So you can't hear that anymore, yeah?
Yeah, I mean, yeah, I think it's fine now.
Okay, good, thanks.
Sorry, my internet keeps cutting out, so I'm having a bit of trouble hearing what's going on.
Because it could, there's a bell ringing.
Let me see if I can stop that.
Thank you. So I continue to see how it goes. With the second industry problem, I came up
Yeah.
with the healthcare. This is this is what in healthcare that I have an example for everyone here. In emergency department, we have an emergency case at 2 o'clock that the patient needs to be treated in 30 minutes. They should be operated. And they look at the story and say, but every surgeons are currently busy in a theater and they cannot have any interruption when the surgery is going on. With IAS that I'm introducing soon, it can go through all of the rules that constraints that we have in the hospital and come up with these three things. Say these three, at least, they are not working together. We cannot have the emergency case here to be treated in half an hour. For this scenario, I don't mean all emergencies should be treated in half an hour. Some of them do. And all of the surgeons are in the theater at the moment. And the patients that have been scheduled to be operated for other patients, they cannot be delayed. They have been fasting and other rules as well. So maybe they cannot be delayed. These are the three things they try to consider at the same time, and the optimization will tell, oh, there's no solution. So you have to think about which one you can play around. And so these are the things that, in fact, both scenario that I explain here, they are solved. Proof the plan has no solution. That's not a bug. This is exactly a diagnosis of a real conflict that is happening. So the question here is, which constraint do we relax and at which cost? and not just second guess it, actually see the reality of that if we to look at the options that we have. So for the audience that we have here in this talk, that they love to see maths and coding, so this is another sweet examples for when we have this is a workforce example. We have the 3 workers. We need to schedule them for 5 working days, and we want to make sure the requirements that we have, we want to make sure that it is 2 hours per shift. We should have someone, and uh, and we want to look at the minimized cost. What is the minimum cost we have? And the right side is an example of this Python code API. Very simple. You introduce your models, your input data, who is available, and you build your optimization model here and add your constraints and objectives, everything, and you optimize it. But when you look at it, run, the model is infeasible. I pause here 30 seconds so that you look at this and you figure out why is it infeasible? How come we cannot have 2 people? We have 3, Hamida, Steve, and Josh. These are the availability, but we cannot have every day 2 people. You can jump in and answer or text whatever you would like to.
Only on Wednesday, only Hamide.
Perfect. That's exactly the challenge. Thank you. That's exactly the problem. But here is simple example. You could see, and then you realize, oh yeah, we don't have some, 2 people on Wednesday. That's the scenario. But imagine when it's the model is more complex in reality, we're working with, thousand millions constraints. It's not straightforward to look at this one. Fantastic. So before jumping and explain, go through the how to go through all of the conflicting constraints. These are what I found it's more common when the model is infeasible. So sometimes just a simple data error. When you're building your model and then instead of saying you need thousands, but you put one more zero and then the solution, all of the complicated problem that you build goes back with an error. And it's hard for everyone to go and then dig into the complicated maths and equations to see which one is causing an issue. And the second common cause is sometimes numerical issue. This is very important because when you're mixing some of the massive and tiny coefficients together and you're making, into the floating point impression, and precision, and which is sometimes you make your model become at the edge of infeasibility, depending on how you define your tolerance in your model. So this is the numerical issues is pretty key. And sometimes users come back and say, my model is feasible, but why telling me it is infeasible? These are, many articles about numerical issues. So be careful when you are defining all of your coefficients and therefore in constraints and even in objective doesn't matter here much, but for infeasibility. And the third other common causes that we found is the modeling trap. Sometimes the constraints of formulation is not correct. It's not meant what you were thinking. And the other things is sometimes you forgot about checking your boundary of upper or lower bound of your decision variables. By default, for example, Gurobi is the lower bound is 0. So everything by default is positive. But in reality, sometimes your model can have negative numbers as well. So just check those upper bound, lower bounds as well. And the fourth one, which is pretty common that you can see, is the hard preference. Sometimes when you're building your model, you might have some hard constraints. Definitely, these are, for example, there's no room you can, a trade-off with them. Like like the some of the safety issues, for example. But in some others that they were talking about the preference of when two coworkers would like to work together if possible. So if you put them in a hard constraints here, the model might be infeasible, and it's hard to navigate all of those when you have lots of constraints. So you can separate them by beautiful multi-objective hierarchical. That's my favorite topic, and you distinguish them from this one. And the last, not the least, is conflicting constraints. When you have lots of constraints, too many constraints, you fit it into your model. Of course, it may be not easy always to be feasible. And also the other things, when you define the new business rules, it may also add conflict to the previous one that was working so far. So these are the 5 common causes of infeasibility. And then before, that's what I thought that would be I can see them in different, from different people. So I thought that would be nice to have summarize them here. So now we have an infeasible model. What do we do? So how we can analyze it? We have 2 scenario, two process I'm going to introduce you here. The first one is irreducible infeasible system. In a very simple terms, you find me what is the conflict here. For example, for tonight, when you're choosing your dinner, you have to think about, what options you have: tasty, healthy, and affordable. You can't have it all the time. So you have to make up your mind and pick only 2. And these are something that you can consider in later. And the next is, okay, fine. Now what is the work around it? My model is infeasible. These are my constraints that are not working together. They have conflict. But I have to have a solution. I have to come up with some proposal when the model is infeasible. So when you have an empty feasible region, which constraints am I going to relax it slightly so I can find some feasible solution? So we call it relax some constraints. I'm going to go deeper into this. First, I start with irreducible and consistent subsystems. This auto one keep running very quick. What is IIS? IIS refers to minimal set of constraints and variable bounds that are infeasible together. And as soon as you remove one of them from the set, the rest will be feasible. That's what it is. At the right side, that's a nice example that we have at the graph. Each node represents one constraint, and each oval can represent one IIS set. So a model can have several IIS sets. And in this small one, for example, you can see if I remove one of them, one constraint, the rest would be feasible. And bear in your mind, you may resolve one of the infeasibility together, but still your model could stay infeasible. For the audience who are interested to know more behind the scene, how this fundamental behind IIS, how this is calculated, for the LP, this is not something very new. This has been out there for years and years. A publication from 1990 by John Gleason and Jennifer Ryan. What it says, the whole story for LP, it says that this paper proved that in the dual Farkas proof, you can generate IES for LP models. How it's working, if you have a system of constraints here, AX less or equals B, in order to make it more X-free, we can add all of those lower bound or upper bound for X into a kind of constraint, so that this become a kind of general system that we have. If you have this system of X less or equals B and X is free, this paper proves that any indices linked to the non-zero components to any vertex or basis of this new system identifies as IIS here for us. And at the right, and if you want to go you can look at in this one in further. And at the right side, I have a nice simple IX example, x equals 1, x equals 2, and x equals 3. We have 3 set of IIS here. And a nice point here is IIS is minimal, not minimal. So what the fundamental behind the IIS that I explained here, this is based on LP. Okay, what you might ask, what do we do for MIP? But unlike LP, where the IIS is tied to a clean dual certificate here, but for MIPS, I mean, in Gurobi, we use this heuristic filtering, deletion, addition to find a minimal infeasible subset. Not necessarily all of them, since the MIP can have multiple IIS and enumerating all is combinatorially interactable, which in optimization we call it is NP-hard. So how we can use this? Let me show you some of the Python API here. What we want to do before that, we want to have the beautiful, simple constraints that are conflicting with each others. We want to understand what are they, and then if I remove single those constraints or bound, the model become feasible. So what we meant here is we want to create those. It's a human readable. It's as much as possible. I don't mean always the case. We can make it small and easier to understand it and digest what's happening. A very important and critical point here that computationally complexity, if it's LP, it's cheap. You can run it, you can find those easily, it's not a problem, most cases. But if it's MIP, sometimes it's very, very expensive to run those. So later I'll show you some of the tricks, some of the features that we have so that you can be mindful when you're computing IIS. The command that we have in, for example, Python, Groovy supports many API. I'm just showing some of the Python API as a start. Check if the model is infeasible, then very simple, model.compute IIS. And a very nice format that we have here, we can write your output of your file into ILP format. Make sure you write it in ILP format because you can see here, this is an example of the original model I show you. It says, okay, this is a very simple shift constraints Wednesday. Hamid the X on Wednesday is 1, and that's the only person that is available on Wednesday. So far we learned that IIS is useful. You can understand this small subset of the constraints that are conflicting and try to understand those. But if it's MIB, I told you it could be complex and it might take a long time to solve it. But in Gurobi, we try to work. They have work on this, not me. All of the beautiful, smart Gurobi developers and R&D team and tech team are working on different algorithm, and we try to improve. They have improved the version every time. So the latest version, as of today, is version 13, and this is an improvement from version 12. And while we have different algorithm here, we have LP, MIP or MIQP, and we also have mean LP. You can see how much improvement has, in terms of the speed has been done for all of the model, and also some of them that are really hard model. For IIS, we can see that has been a massive improvement from the version 12 to version 13 to calculate that, and 67.8%. The story behind this massive improvement, I thought to share, that would be nice for you to see what happened. For those people who has used Groby for several versions, in Groby 9, they start to just estimate, sorry that it's keep moving. In version 9, we used to initially simple estimate how big is when we are calculating IIS, how big it is. And in using the maximum likelihood estimate, we introduced that one in version 10, and we use that MLE into as a guess. What's the size of IAS? We just guess it, and we use that one behind our heuristic to figure out how it's useful. Here is in the Groby locked file. You can search, in the constraints, and it says, okay, min, max, and then, for example, here it says the min is 14, and then maximum 67, and they're guessing 43 should be this, this the route that we are going through to find IAS here. And we use it as just a report apparently before, but now it's helping the heuristic to use it faster. So these are something very interesting features, advanced features that, as I say, it's not just magic. Go and use, compute IIS. For me particularly, you have to use some modeling features as well, especially if it's really big model. First, we have some, IS method for solving to calculating. You can use it. If you want your model is, you just want something fast, tell you what is it, you can use the model zero, method zero. It will be very fast and give you some IS to look into that. But remember, it might be a larger IS. You might throw a huge number of constraints, say all of these are not working well together, and you have to go through each. But if you want to spend more time, but you have a smaller IES set so that you can, easier to read and investigate, you can use the method one. And we have two other methods as well. And I thought to share some of the features, advanced features, when you're using, with IIS calculation, it is important. You use your knowledge. Sometimes you know that the new rules, business rules, that the stakeholders ask to put into your model, and then it says, bang, and that new business rule made some, infeasible, bring up some infeasibility. So you can use, for example, IS constraint force. You say, whatever you're doing, whatever you're searching for a calculation of IS, make sure include these new rules that I put, and then help you to understand which other, which one is conflicting with at the moment. And there are other features as well. You can look into the definition of each of these later. And the other point that I want to share here is, sometimes the model, make sure if you're writing the production and you want to know, this is small things that I noticed that sometimes you want to know if, you want to query the unbounded array of unbounded models, or if it's infeasible, you want to have a proof. Because if you don't put that parameters equals 1, then without that one, the more optimized, it goes, this is a log file, and at the end, by default, sometimes it says model is infeasible or unbounded. It doesn't, and then sometimes you need to know, okay, which of them. Either you can use the inf on this parameter equals 1, which, bear in your mind, it might be expensive in terms of the computational for you if you put this 1. If you don't want that one, the other option that you can consider, which is, you want to, say, I don't want more information. I just need to know which one it is. You can use dual reduction. This is one parameter that's in Groby that's useful. You can put it equals 0, and then it will exactly tell you which one your model is. Is that infeasible or unbounded? So far, we learned about IAS, and then you understand what's conflicting with what. That's the cool things to know. But you cannot just go to your, if your boss and says, okay, the solution doesn't work, they're conflicting. It's always good to have with some proposal as well to say, okay, what do we do next? So we call it Fizz Relax. What's the story of before Fizz Relax? This is modifies your model to make it feasible. You say, just I need to have some feasible solution. I cannot have infeasibility. I mean, mathematically, it's simple. It says, let me put this one up. So mathematically, it says if you have an infeasible model, we just add select variables to the our rules, constraints, and also the bounds, and say, now minimize the violation for me. And that's how you generate some solution which is not which is definitely will be feasible. But how much we are relaxing, this is depending on the scenario by scenario. So the nice things here, we have two APIs. The first API is we call it Fizz Relax S to be simple. And we have some parameters here that based on each scenario, you have to think about what is the best things you can do. Relax object type. This is very fascinating. When I look at different scenario in this one, you can think about it, whether you want to have, you want to minimize sum of violation, or you want to have the L2, I mean, if you put number one is sum of, you want to minimize sum of square of violation. And the third option you have, you can have count of violation. So you may think, what is the difference? Imagine if you have in your demand, you look at it, I'm thinking, oh, you have 20 units of something, and your shortage of 20 units in your supply and demand. What do you do? Do you want to have, 19 customers that they have on the requested only one, and then only one angry customer? Or you want to be fair and then spread around that, the shortage that you have? This is something that it helps you to understand which, relaxed objective you can introduce. And the other things here is you can just say, just minimize, if you want to just minimize the violation, at the end, you can also say minimize violation. And after you do that, tell me what is the original objective, optimize the original objective. So you can say at which cost you are relaxing those constraints. That's a very powerful tool. And this is an example that I keep saying, this is what we're not second guessing, we're just actually validating with the true numbers to see what it is, because the industry keeps changing. It's not it, and it doesn't stay the same. So we have to be ready by compromising different rules that whatever happening, and then see which one is the best for each scenario. The second API that exists at the moment with Groby API is the advanced one. We have the same relax object type that I explained it before in the simple one. The other things, sometimes you say, okay, you want to have a control on relaxing. So you want to relax some of the variables that, these are the variables, you're comfortable with them to play with their bounds. Or sometimes you want to penalize some of the, upper or lower bounds on each variable. And the other things is you want to control to say how much constraints, which constraints you want to relax. You don't want to relax everything. You have a set of constraints. You say, with these, I'm happy to, they're pretty soft, and then I'm happy to play with them. But if you have some critical constraints, you don't want to play with those. So definitely with you can give a high penalty on those constraints to say, do not play with this, do not relax, don't go near those constraints because these are critical, like safety, they're related to safety matters of the workforce. So there's no room to negotiate in that aspects. But for the rest, you might. So that's a good things to know. And depending on the scenario by scenario, this is as I said, you need to definitely understand your business rules here before you can do anything. If it's a mining problem or if it's a rail scheduling, everything, you need to know which part is more important. And let's go back to the original problem that I said workforce optimization. So if, we had three people, Hamida, Josh, and Steve, we couldn't, we assigned two people. This is a simple example. You look at it, and then this is a nice API. It says, check, the status is infeasible. And then you say, okay, I'm going to define my penalty for each day. And then now you say, okay, fees relax. And now you optimize it. And this is the results that at the right side, you can see the log file. It says this, you have a schedule. Okay. And then it will tell you, finally, we have a schedule, but this is the Wednesday that we couldn't be satisfied with the rules that you set up. The next example that we discussed earlier in the talk was about the airline. Yeah, IAS came back and says these three rules were not satisfied. We had an airline canceled, 180 passengers, we had only 140 seats available. These were the rules. We have to send them everything today, and we cannot over capacity the rules, and there's no stop rules. So when IAS can help, to identify the three conflicts, and then with the fees relax, you can look at them and say, okay, these are the options that you have. You can be relaxed with everyone should, rebook today to, no, sorry, 140 can be, we can direct flights today, and the remaining 40 should be rebooked today. These are one option. And the second option is you had the non-stop rules for 40 passengers, and then we can reroute them with, for example, through the Canberra. The good things with this one, it will allocate, okay, what is the cost associated to each of these at the moment? It can come back and link the cost that is linked to each of these options. And this is a good thing for the stakeholders, can look at it, validate those numbers, and see which one matters in the airline industry. The healthcare example that I earlier discussed, that emergency patients arrived, and then IS finds that we cannot, there's no possibility that we can schedule these emergency patients because of, all surgeons are in the theater, and then these patients should be operated in 3 minutes. What are the options? Maybe the surgeon availability give +1. These are the maths number. It can comes back and say, do we have option +1 call, on-call surgeon? So we relax the surgeon availability to see the good things is emergency begins on time with no impact on the scheduled patients. And the other options, if he's relaxed, can say delay or postpone the next schedule elective. Too bad we tried because unfortunately patients are fasting sometime. But if that's the case, then these are the options that clinicians should decide. Even sometimes there are hard decisions to need to make decisions. And these fees relax options by penalty. Yeah, clinical teams finally call to say what is the best scenario they can consider. And these are everyday things. So IAS turns, no solution into precise question here. And the fees relax turns the question into concrete options so decision maker can act on it. They can validate what is the effect of each of them. The best practice that after going through all of this, we notice this is definitely remember, write IAS when you calculate them into ILP format. It's much easier to read them. And check IAS's minimal attribute to see the quality of IAS you have. You may have other IAS. You might still have smaller sets as well. So you can check that. And when you're using fees relax, you can use penalty to protect your critical constraints that you don't want to relax them. For example, the previous scenario, when the patient is doing surgery, you cannot cut the patient, wake up the patient in the middle of surgery and says that there's emergency coming, because these are the maths. You need to be careful how to use them as well. And you can use the IES force attribute for complex models to focus where to search, because some of these takes ages to run. And in Groby, we have model analyzer. You can use that one, analyze your results, see have the sensitivity analysis as well. But something that we think you need to be mindful and do not do them. Do not think IS is the smallest possible subset. I said this is NPR problem. We cannot guarantee this is the smallest subset. And also don't expect IS to be unique. There could be several subsets that are conflicting together. And also don't forget to use time limit when you're calculating MIP model because sometimes it's difficult. It takes ages. Don't forget to use variable lower bound, upper bound. And numerical issues, sometimes the model is feasible, but it's just infeasible. Be careful with that as well. And I wanted to pause here and show you the recent update that we have in Groby, which is about the intelligent hub. Because sometimes everyone says, how can I interpret? It's not easy. Yeah, it has been there for decades, these kind of IIS is relaxed, but it's not interpretable. But it's getting better and better. It's faster now. And also you can interpret by the use of AI that many of us are using at the moment. This is the key time for us, and we can get through this. We recently launched the Groby Intelligent Hub, which has definitely, I recommend, and this is free, and you can look into that. This is free for everyone. They can register and then look into this one. And we have 3 different, Gorobot, this launch, I think it said more than a year. And you can ask your questions like ChatGPT or Claude, whatever you're using. And it helps you with, it's trained on a Gurobi optimization and also some of the articles as well. We have modular and the explainer. This is where, related to our infeasibility, I recommend you look into this infeasibility in explainer, and then it helps you to navigate further. There are others you can play around this one. And when you click on Infeasibility Explainer, what's happening? This is infeasibility diagnosis, feasibility restoration, and sensitivity analysis. This is what I was explaining so far. What is IIS? You can put your, LP format, upload it here, and then start to have dialogue. What do you get out of all of, you say, this is my 150 constraints in ILP. I cannot get any sense out of it. How can I use that? This was a bottleneck before in terms of interpretability of IIS before, if the model was hard, but maybe not anymore. Try this one. Tell me how you go. And if you have any questions, that's interesting to see what you come up with. Try that. That's new. To summarize, so first, the whole workflow, confirm it is infeasible. Make sure you use some parameters like joule reduction to 0 so it's not inbounded. Then you calculate IIS, compute IIS, and then write it ILP file to be readable. Look at them, understand what is conflicting with what. Does it make sense to you as well? And then you can start to apply phase relax to see which constraints you can relax. And at the end, use explainer. Recover workable solution, how you can get it, and you have something in your hand when you're meeting, helping your stakeholders to make a decision. These are some of the resources that I'm happy to share slides with anyone who is interested. And then I also add some, the intelligence and explainer, intelligence hub that we have, and explainer, just ask. I heard lots of good things about Gurubot. I was at a customer workshop, and then at the end, one of the optimization expert, she said Gurubot was her best friend the whole year. Have a go. I hope it will be useful for you.